Hi guys, welcome back to the channel. In this lecture, we are going to calculate the collapse load for this frame structure. Okay. So basically in this problem, we need to calculate the value of W at collapse, right? So this is a portal frame which is unsymmetrical in geometry and unsymmetrical in loading, right? So to calculate the collapse load, or you can say to calculate the collapse, or you can say that to calculate the value of the W, we need to first calculate what is the static indeterminacy of this frame. Okay, to approach these type of problems, first step is need to calculate the static indeterminacy of the frame. Okay, so if you calculate static indeterminacy of the frame, we will be having two reactions at this support, right? One vertical and one horizontal, right? At this support, we will be having three reactions, one vertical, one horizontal, and one moment will be there, right? So total number of reactions are 5. And equilibrium equation are 3. What are the equilibrium equations? Summation fx0, summation fy0, and summation m0. Okay. So equilibrium equations are 3. So static indeterminacy will be 2. Okay. Next step is to calculate the location of plastic hinges. Okay. To identify location of plastic hinges. Okay, so plastic hinges, where plastic hinges can form in this frame, we need to identify those locations. Okay, so first plastic hinge can form at this point. Okay, second plastic hinge will be formed at this point. Okay, third plastic hinge will form at this point. Fourth will be here, and fifth will be at this point, right? So in the diagram, we are saying that the plastic hinge will be forming at this joint. Actually, it is not forming on the joint. It will be formed on the weak member. Okay. So basically, we will be having 5 locations where the plastic hinge can form at this point, this point, this point, this point, and this point. Okay. So total number of location of plastic hinges n is equals to 5, right? Static indeterminacy is 2. So number of independent mechanism will be 5 minus of 2. So that will be 3. So in this problem, the total number of independent mechanism will be 3. Okay. So we will be having two beam mechanism and one sway mechanism. Okay. So two beam mechanism will take place in the, if let us suppose this is A, this is B, this is C, this is D. So two beam mechanism will take place in the member BC and CD. Okay. This distance is 3 meter. This distance is again 3 meter. Right. And one sway mechanism will be forming on this complete structure. Okay. So first we will be calculating what will be the collapse load for the beam mechanism in the member BC, or you can say that in the beam BC, right? So considering member BC, considering mechanism in BC member, right? So if mechanism is taking place in BC member, we will be having 3 plastic hinges. 3 plastic hinges should form in this BC member. And during collapse, it will deflect like this. This is during collapse. Okay. So this rotation in the remaining frame will look like this. The remaining portion will look like this, right? Here the W load is acting. In the beam mechanism of BC member, this load is of no use, right? So now let us apply the principle of virtual work done method on this beam, on this part. the direction of the rotation will look like this. Okay, and this is basically theta, right? So if you apply the principle of virtual work done, principle of virtual work done, which state that external virtual work done will be equal to internal virtual work. And the virtual displacement is basically theta. Virtual displacement is, this theta is basically virtual displacement, right? This theta is basically the virtual displacement. Okay. So what will be the external work done? External work done will be, this distance is 5, this distance is 5. External work done will be W into this distance, this delta. Okay. And the delta value will be equals to 5 into theta. Right? So external work done will be W into 5 theta. Okay. And internal work done will take place at this hinge, and at this hinge. At this hinge will form in the column because this MP value is less as compared to this. The MP value of this column is less than the MP value of this beam. Okay. So I need to write MP into theta. Plus here also I need to write 2mp into theta plus 2mp into theta. Okay, at this point this hinge is forming on this beam, so that's why we are taking 2mp. Okay, we are not taking mp only, right? Plus here also the plastic hinge will form in this column, and we are showing it in joint, but actually this plastic hinge will form in the column. So it will be 1.5 mp into theta. Okay. So if you calculate this thing, so this will be 6.5 mp into theta, and this is equals to 5 theta. Theta will cancel out each other. So W will be equals to 6.5 divided by 5. So W is equals to 1.3 of mp. Okay. So when the beam mechanism is taking place in BC member, then the value of collapse loads comes out to be, the value of the W comes out to be 1.3 mp. Okay. So let us suppose this is mechanism 1. So mechanism 1 is beam mechanism in BC, and the value comes out to be W equals to 1.3 of mp. Let us suppose this is mechanism 1, right? Now let us talk about mechanism 2. So in mechanism 2, I am assuming that in mechanism 2, the mechanism will form in this column. The beam mechanism will form in this CD column. Okay. So now in mechanism 2, beam mechanism in column A, D, C. Okay. When you are saying that mechanism is taking place in this column, the plastic hinge will form at this C point. Okay, at this point, and at this location of the point load, and at this support. Okay, because these are the points of peak bending moments, right? So if we see in this diagram, the beam mechanism in member in the column will look like this. This is theta, this is theta, right? This is theta, and this is theta. Okay. So this is CD. So again, if you apply the principle of virtual work done, where external work done is equals to internal work done, right? So at this point, location of the plastic hinge, the internal work absorbed will be 1.5 mp into theta, okay, plus at this point it will be 1.5 mp into theta, plus at this point it will be 1.5 mp into theta plus 1.5 mp into theta. The direction of the movement will look like this. The direction of the plastic movement will look like this, okay, and this will be equals to external work done. External virtual work done will be due to this load, and its value will be 0.5 W into this delta, okay. So this delta is equals to 3 theta, right? So I can directly write 0.5 W into 3 theta, okay. This is basically, this expression is basically internal work done and this is external virtual work done, right? So it will be 4 divided by. So the value comes out to be theta, this is 6 mp theta equals to 1.5 W into 3 theta, okay. Theta will cancel out each other, so this will be 4 mp is equals to W, okay. So when you are saying that beam mechanism is taking place in this column CD, then the value of load W comes out to be 4 mp, right? So now let us come to the sway mechanism 3, which is sway mechanism. Okay, so this sway will take place in the whole structure, right? So as we have discussed in the last lecture, in sway mechanism, or you can say that in panel mechanism, the plastic hinge will form at the top and the bottom of the columns, okay. So when this member, when there is sway mechanism in this structure, it will look like this, okay. The plastic hinge will form at this point, and again at this point, right? So at this point there is a load acting which is 0.5 W. Here also one load is acting which is 0.5 W, okay. So this load is of no use. Now let us suppose this is our initial axis, initial vertical axis, this is also initial axis, okay. This delta, let us suppose this sway displacement is delta and this delta will be equal, okay. This delta 1 and delta 2 will be equal. Why equal? Because we are considering member inextensible, okay. So when you are considering member inextensible, this delta 1 should be equal to delta 2, okay. Let us suppose this rotation is theta, okay. This distance is 4 and this distance is 6, and let us suppose this rotation is theta 1, okay. Now what will be the relation between this theta and theta 1? We need to calculate, okay, because we will be writing our virtual work equation in terms of single virtual displacement. Here this virtual displacement is theta, okay. So I can write this delta 1 is equals to delta 2. Delta 1 will be 4 into theta and this delta 2 will be equals to 6 into theta 1, okay. So from here 2 by 3 theta will be is equals to theta 1, okay. So I am writing this relation over here. Theta 1 will be equals to 2 by 3 of theta, okay. Now if you apply the virtual work done equation in this sway mechanism, this is the point of natural hinge, so no work done will be here. Okay, so the work done, the internal work done will be at this plastic hinge, and the value will be mp into theta plus, again the work done will be here in this plastic hinge which is forming in the column, because column is a weak member as compared to beam, right? So this will be equals to 1.5 mp into theta 1. So this is theta 1 basically, right? Plus 1.5 mp into theta 1, which is equals to, what is external work done? External work done will be 0.5 w into 3 theta 1 plus 0.5 w into 4 theta. Okay, external work done will be due to this load and this load. There is no external work done due to this load. Okay, so this will be, if you put the value of theta 1 in this equation will become 2 by theta plus 1.5 mp into 2 by 3 of theta equals to 0.5 w into 3 into 2 by 3 theta plus 0.5 w into 4 theta. So this will be our equation. If you put this value of this theta 1 into this equation, right? And if you calculate this value, this will be this will be 3 mp theta, and this will be equals to 3 w theta. So theta will cancel out each other, 3 will cancel out each other, so w equals to mp. Okay, so if you are considering the sway mechanism which is mechanism 3, the value comes out to be w is equals to mp. Now you can see that out of these 3 critical mechanisms, the sway mechanism is a critical one, but we will also be checking some combined mechanism. Okay, so basically, let us discuss about combined mechanism. Okay, so combined mechanism, it is basically used to cancellation of hinges will be there. Okay, cancellation of hinges will be there, right? And due to which the internal work will become minimum. Internal work will become less. Okay, due to which you will be getting more critical value of w. Okay, this thing we have already discussed in the last lecture, right? Now we are having 3 mechanisms. This is mechanism 2, this is mechanism 3. So let us suppose first combine mechanism 1 and mechanism 2. Mechanism 1 and mechanism 2. Okay, now see it very carefully. Okay, due to the mechanism 1, the displacement of the beam was looking like this. This is mechanism 1. Okay, this rotation is theta, right? Now plus, if you add mechanism 2 with mechanism 1, the displacement of this column in mechanism 2 was looking like this. Okay, this rotation, this is theta, this is again theta, this is theta, and this is theta, right? Now you can see that if you add these 2 points, if you see these 2 points, plastic hinge will form here. Okay, because the two members are rotating, because there is a net rotation in the member which is less than 90 degree, right? Here the rotation is theta in this direction. So if you combine these two points, okay, so net rotation will be in this direction, right? So you can say that this angle between these two members is less than 90 degree. So there will be plastic hinge formation will be here. Okay, so plastic hinge will form at this point, right? At this point also plastic hinge will form. Same reason. Okay. Now if you see this point, see this is important thing. If you consider this C point, you can see that this due to this rotation which is anti-clockwise, this portion is rotating in this direction, right? And again this member is rotating in this direction. The situation is like this. Initially the angle between these two members is 90 degree. Okay. So due to B mechanism, this portion moves by theta, okay, in anti-clockwise direction. Similarly, due to B mechanism in this CD portion, this member moves like this by theta. So you can see that now also the angle between these two members is 90 degree. So there will not be any plastic hinge. Okay, if there is plastic hinge, then there should be the angle between two members should be different than 90 degree. Okay, so there at C there will be no hinge. There will be no hinge, right? You need to understand this thing very carefully. Okay, and at this point also hinge will form. Okay, because at this point there is no hinge, and at this point there is a hinge. So if we add these 2 points, if we consider these 2 points, then hinge will be there. Similar case goes for here also. Okay, so now our deflection during the collapse, if you combine these two diagram, will look like this. Let us suppose this is initial frame, and if you combine these two members, the plastic deformations will look like this. Okay, so plastic hinges will be forming at this B point, and at this point, and this point. Okay, so by combining mechanism and mechanism 2, we are able to cancelling this hinges at this point. Okay, so this load W is acting, and at this point the load 0.5 W is acting. Okay, there is no use of this load. Okay, so if you apply again the principle of virtual work done method, so I will be writing MP into theta for this point. For this point it will be 2 MP into 2 theta. Okay, or you can say that 2 MP into theta plus 2 MP into theta, plus there is no hinge at this point, so we need not to consider this C point, right? Plus 1.5 MP into theta plus 1.5 MP into theta, and plus here also 1.5 MP into theta, and this will be equals to, what is the external virtual work done? It will be equals to W into 5 theta plus 0.5 W into 3 theta. Okay, I hope this point is clear to you. Why hinge is not forming at this C point? So if you see this thing, if you calculate this thing, so this will be 4, 5, this is 1 plus 4 plus 4.5. So this is 9.5 MP theta equals to, this is 5, this is 6.5 W into theta. So theta will cancel out each other. So 9.5 divided by 6.5, this is equals to 1.461 MP equals to W. Okay, so when you are combining this mechanism 1 and mechanism 2, mechanism 1 and 2, you are getting the value equals to 1.461 MP equals to W. Okay, so now this is okay. Now let us combine mechanism 1 and mechanism, let us combine mechanism 2 and mechanism 3. Now if you combine mechanism 2 and mechanism 3. Okay, so what will happen? So in mechanism 2, if this is our frame, and during in mechanism 2, the plastic deformation of this column was looking like this. This is theta, this is theta, this is theta, and this is theta. So basically the plastic hinges are forming at this point, and at this point. So if you combine this mechanism with sway mechanism, here the plastic hinges at this point, then at this point. This rotation was 2 theta by 3, we have already discussed. This is 2 theta by 3, here it was theta, and here it will be theta. Okay, now we need to combine these two mechanisms, and we need to see, is there any possibility of cancel of hinges is there or not. Okay, whole purpose of combined mechanism is to find the critical value of the load. Okay, how we can form the cancellation of hinges, that is our main criteria, right? So if you combine these two mechanisms, first we will be see this point, this B point. Okay, B point, in this mechanism the angle between the member is 90 degree, and at this point this is rotated by theta. Okay, so net rotation at this point, the angle between, if you combine these two things, the angle between the member will be more than 90 degree. Okay, so plastic hinge will definitely form here. Okay, so plastic hinge will be forming over here. Why? Because if you combine these two, so this portion will look like this. Okay, so angle between these two members is greater than 90, so plastic hinge will form there, right? So at B, plastic hinge will be there, right? What about C point? What about C point? At C, you can see that. At C, you can see that in this portion, it is rotating in anti-clockwise direction, in mechanism 2 by theta amount. Okay, and this portion is rotating by 2 theta by 3 in clockwise direction. Okay, so net rotation at this point will be theta minus of 2 theta by 3, which is equals to theta by 3. Okay, so at this point, if you see at this, initially the angle between the member is 90 degree, right? And if you combine these two things, it should look like this. So this will be the rotation, theta by 3. This is the final situation of the point C. Okay, when you combine these two mechanisms. Okay, at this point there is a rotation of theta by 3 from this vertical axis to this member, right? So at C, the angle between these two members is greater than 90, so plastic hinges will be there. Okay, so again at this point also plastic hinge will form, because at this point there is no plastic hinge. So if you combine these 2 points, the plastic hinge will be there. Okay, similarly at this point also plastic hinge will be there. Why? Because here you can see that the rotation is in anti-clockwise direction, clockwise direction. And what is the rotation? It is 2 theta by 3. Similarly at this point the rotation is theta. So total rotation from vertical axis will be theta plus 2 theta by 3. So that will be equals to 5 theta by 3. Okay. So plastic hinge will be there. So if you combine these two mechanisms, the deflection diagram will look like this. This theta is basically 2 theta by, this theta is theta by 3. Okay, this is delta, this is delta, this is theta, this angle will be 5 theta by 3, 5 theta by 3, this angle will be 5 theta by 3, this angle will be theta by 3, right? So plastic hinges are forming at this point, this point, this point, and this point. Okay, there should be no doubt in this. You need to carefully check the rotation direction. Okay, so this is theta by 3. So in the deformation, when the plastic deformation in the collapse is taking place, the deflection, the plastic deformations will look like this. Okay, right? So if you apply again what you can say that principle of external work done or internal work done, this point there is a load 0.5 W, here also one load 0.5 W. So if you apply what you can say that the principle of virtual work done, what is the value of external virtual work done? It will be 0.5 W into 4 theta. This distance is, this vertical length is 4, this is 3 meters. Right, plus external work done will take place at this load, at the position of this load. So it will be 0.5 W into this distance will be into 3 5 theta by 3, right? And this will be equals to internal virtual work done. Internal virtual work done will take place at the hinges location. Okay, so here the work done will be MP into theta, MP into theta, plus coming to this point, it will be net rotation at this point is theta by 3. This angle is 90 degree, so angle more than 90 degree we need to consider. So it will be 1.5 MP into theta by 3, right? Plus if you come to at this point, here the value will, here the virtual work done will be 1.5 MP into 5 theta by 3 plus MP 1.5 MP into theta by 3. And again plus at this point it will be again 1.5 MP into 5 by 3 theta. Okay, this is the value of internal virtual work done. You need to carefully understand this. Okay, this is very important thing. Right, so if you calculate this thing, it will be 5 into 4 plus 0.5 into 5. So this is 4.5 W theta, and this is equals to, this will be equals to, this is 1, this is 0.5, okay, this is 2, this is 2, this is 1.5 to 5 divided by 3, 2. This is 7. Okay, so the value comes out to be, W comes out to be 1.55 MP. Okay. So if you combine mechanism 2 with mechanism N3, the value is 1.55 MP equals to W. Okay, so this is the result of combining mechanism 2 and mechanism 3. Now let us combine mechanism 1 and mechanism 2. Mechanism 1 and mechanism 3. And mechanism 3. Okay, mechanism 1 and mechanism 3. Okay, so now let us see what is mechanism. In mechanism 1, the plastic deformation were looking like this in the beam. This is theta, and this is theta, this is theta, right? This is A, this is B, this is C, this is D. And if you combine it with sway mechanism, the sway mechanism deformations were looking like this. This is theta, this is 2 theta by 3, this is 2 theta by 3, this is C point, this is B point, and this is A point, and this is D point, right? So now if you combine what you can say that these two mechanisms, at B point we will be checking whether the plastic hinge is there at B or not. Okay, so if you see at B point in beam mechanism, it is deflecting like this in this direction, theta, in clockwise direction. Okay, similarly in the sway mechanism, what is happening is that this member is rotated by theta in clockwise direction. Okay, by same amount. This theta is same. Okay, so if you combine these two things, it will be look like this. Okay, so you can see that initially the angle between the members is 90 degree. Again, if this member is rotated by theta in clockwise direction and this vertical member is also rotated by theta, still the angle between the two members is 90 degree, right? So there will be no plastic hinge at B. No plastic hinge at B. At this point, plastic hinge will be there because in sway there is no hinge, in beam mechanism there is hinge. If you combine both two things, then plastic hinge will be there. Okay, this thing also we have discussed in last lecture in detail, right? Now let us come to this C point. C point, if you see in beam mechanism, this is rotated by anti-clockwise by the amount theta. Okay, and in sway mechanism, this is rotated by 2 theta by 3. So if you combine both these two things, so at the C, this is our the plastic the rotation at C will look like this. This is theta, this is 2 theta by 3. Okay, so initially the angle between the members is 90 degree. Now angle is changed. What is angle between now? Angle will be nothing but 90 minus theta plus 2 theta by 3. So change in angle between these two members now is theta plus 2 theta by 3. So plastic hinge will be there. Okay, so plastic hinge will be there, right? And while writing the internal virtual work done, I can directly write 1.5 MP into this change in angle. This is theta plus 2 theta by 3. Or separately also I can write 1.5 MP into theta plus 1.5 MP into 2 theta by 3. Okay, so plastic hinge will be there at C. At D there will be plastic hinge because at this point there is no plastic hinge. So if you combine these 2 points, plastic hinge will be there, right? So now let us draw how it will deflect, in how the plastic deformation will look like when you combine these two mechanisms. So let us suppose this is our initial frame. So after deflection, during collapse, the deflection will look like this. this is theta, this is 2 theta by 3, this is 2 theta by 3, this is 2 theta by, no sorry, this is theta, this is again theta, this is theta. Okay, so plastic hinges are basically forming at this C point, this D point and this point. Okay, and the external virtual work done will be due to this load, which is 0.55 W, and in here also it is 0.5 W, right? Now apply principle of virtual work. Principle of virtual work. So what is external work? External work done will be 0.5 W into 4 theta, right, at this point, and again at this point it will be 0.5 W into 3 into 2 by 3 theta, 2 theta by 3, right? This angle is 2 theta by 3. Okay, and at this C point, now internal work done will be equals to this point, the internal virtual work done will be 2 MP into 2 theta plus, why 2 theta? Because net rotation is 2 theta. This is 2 theta. Okay, I can separately write 2 MP into theta, or 2 MP into 2 theta I can also write, plus 1.5 MP into theta plus 1.5 MP into 2 theta by 3 plus 1.5 MP into 2 theta by 3 at this D point. Okay, and if you solve this equation, 0.5 into 4 plus 0.5 into 2, so this is 3 W theta equals to 4 plus 1.5, 4 plus 1.5 plus 2, this is 7.5 MP into theta. Okay, I forgot to write external work done will be due to this load also. So this is plus W into this distance is 5 theta. So this value is 8 W theta equals to 7.5 MP into theta. MP theta into 2 MP theta plus 1.5 MP into theta plus 1.5 MP into 2 theta by 3, and again this is 1.5 MP into 2 theta by 3. This value will be 4 plus 1.5 plus 1.5 into 2 by 3 plus 1.5 into 2 divided by 3. So this is 7.5. So the value, this is 2, 3, this is 8, so 8, okay, this is 8, so theta cancel out each other. So here 7.5 divided by 8 MP is equals to W. Okay, so this value will be 9.375 MP. Okay, so if you are combining mechanism 3, if you are combining mechanism 1 and 3, the load value comes out to be 0.9375 MP equals to W. Okay, so you can see that out of these 5 mechanisms, in which 3 are independent mechanism, 3 are combined mechanism, the critical value is 0.9375. Okay, now let us see what happens if we combine all 3 mechanisms. What will be the collapse load value W? Okay, so guys, now we will be combining this mechanism 1 means all three mechanisms we are combining. Okay, mechanism 1, mechanism 2, mechanism 3. Okay, so combining mechanism 1, mechanism 2 and mechanism 3. So what critical value of load we will get, we'll see now, right? So now let us draw first mechanism, which was beam mechanism. Okay, in the beam mechanism, the plastic deformations were looking like this. This is theta, this is theta, and this is theta. Okay. Similarly, in the beam mechanism, in this column, was looking like this. The plastic deformation, this is theta, this is theta, this is theta, and this is theta, right? And if you add sway mechanism also, right? Now, we know that in the beam mechanism, the plastic hinges are forming at this B, this point and this C point. Okay. In the beam mechanism in this column, the plastic hinges are forming at this point and this point, right? In sway mechanism, the plastic hinges are forming at this point B, C and D. This thing we have already discussed, right? Now let us see each point or each joint we'll see, and we'll see whether there is any possibility of cancellation of hinges is there or not, because ultimate purpose is that only. Okay, so this is B, this is C, this is A, this is D, A, B, C, D, A, B, C, D. Okay, so now let us first discuss about this P point. Okay, point B. So at point B, in the initial angle between these two members is 90 degree. Okay, so if plastic hinge need to form at this point, this angle, the angle between two members, should be greater than or less than 90 degree. Okay, so now if you combine these two mechanisms, if you combine all these three mechanisms, so due to this way, this member rotate in the clockwise direction by theta amount. In beam mechanism, this member rotate in clockwise direction. Okay, and in this beam mechanism in this column, there is no effect. Okay, this angle is 90 degree. Okay, so if you combine these two mechanism only, because here the angle is, there is no plastic hinge, the angle between them is 90 degree, right? So if you combine these things, so net plastic deformation, the plastic deformation at B will look like this. This is theta, this is theta. So you can see that this member is coming out by theta in clockwise direction, and this member is also rotating in clockwise direction. So there will be no plastic hinge at this point B. Okay, no plastic hinge at B, right? Very, very important thing. Okay, plastic hinge will form at this point because in sway there is no plastic hinge, in this there is no plastic hinge. So if you combine all these things, there will be net rotation. Okay, so plastic hinge will be at this point. There is point load is acting. Okay, similarly plastic hinge will also form at this point. In this there is no plastic hinge, here also there is no plastic hinge. So if you combine all this at this point, plastic hinge will form. Okay, plastic hinge will be there. At D also there will be plastic hinge because both the rotations are in clockwise directions. Okay, now the important thing is C point. You need to understand this thing very, very carefully. Okay, so now we will be seeing some very important thing over here. At C point, initial angle between the members at C point is 90 degree. Okay, initial angle between these two members is 90 degree. Now In this beam mechanism, we see that this member is rotating by theta amount in anticlockwise direction. Similarly, beam mechanism in this column, this member is rotating by theta amount. Okay, and this member is rotating by 2 theta by 3. 2 theta by 3. This member is coming by 2 theta by 3. So net rotation of this vertical member will be theta minus of 2 theta by 3. Okay, so at this point, this angle is basically theta by 3. Okay, once again we can see that, okay, because this is a very important concept. Initially the angle between the member is 90 degree. Okay, in beam mechanism this portion is rotated by theta amount. In this beam mechanism, this vertical member is rotated by theta amount in anticlockwise direction, right? Here you can see that there is a clockwise rotation in this vertical member. So this vertical member should come down by 2 theta by 3 amount. So this angle is 2 theta by 3 and this angle is theta by 3, right? So what is our member rotation at C will look like? Final, okay, this is theta, this is theta by 3. Okay, now if someone asks you, initially the angle is 90, if this is theta, this is theta by 3. Okay, initial angle between this member is 90 degree. Okay, and so the angle between these two members is basically less than 90 degree or more than 90 degree. Okay, but it is not 90 degree because this is theta, this is theta by 3. If this has been theta, then there will be no plastic hinge, but this is theta by 3 if you combine all the rotation at this C joint, right? So now if someone asks what is the angle between the members, now the angle between the members will be this one. And what is this angle? What will be this angle? This angle will be 90 minus what will be the angle will be 90 minus theta by 3. Okay, so it will be equals to 90 minus 2 theta by 3. So here the net rotation between the member is basically 2 theta by 3. Okay, so if you calculate the internal work done at this hinge, it will be 1.5 MP into 2 theta by 3. Okay, because when we write internal work done at this point, what we write? MP into theta plus MP into theta. So you take MP common, 2 theta. MP into 2 theta. 2 theta is basically net rotation. So here the net rotation is 2 theta by 3. So we need to write 1.5 MP into 2 theta by 3 because this rotation is also in clockwise direction and this theta by 3 is also in clockwise direction. Okay, so you cannot write 1.5 MP into theta plus 1.5 MP into theta by 3. Okay, this will be wrong. Okay, this will be wrong. Okay, this will be wrong, right? Because net rotation is not theta plus theta by 3. Net rotation is basically theta minus of theta by 3, which is equals to 2 theta by 3. This you need to check, and this you will came to know if you know that how the rotation is taking place. Okay, so this is the very important concept which we learned over here. Okay, now if you see, so plastic hinge is forming at this point, C point. Now we will be drawing the plastic deformations. Okay, so the plastic deformation, if this is the initial structure, initial portal frame, the plastic deformations will look like this during collapse. This angle will be 2 theta by 3 plus theta, theta plus 2 theta by 3, right? This is theta plus 2 theta by 3. Okay, so this is our plastic deformation during collapse will look like. Okay, there is no plastic hinge at B. Plastic hinge will be there at this point, and this point, and this point. A is natural hinge point. Okay, this is 0.5 W, this is W, this is again 0.5 W, right? Now, if you apply the principle of virtual work over here, first we will be calculating the internal virtual work done. Internal virtual work done will be, this is theta, this is theta. It will be 2 MP into theta plus 2 MP into theta, plus at 2 MP into theta, this point is the internal virtual work done for this hinge we wrote over here. Okay, now for this hinge the internal work done will be 1.5 MP into theta minus of theta by 3. Both the rotation in same, this rotation is in same direction. That's why I have write theta minus theta by 3. Okay, this value is basically equals to 2 theta by 3. Okay, so I will directly be writing 2 theta by 3 plus at this point the internal virtual work done will be 1.5 MP into theta by 3 plus 1.5 MP into 5 theta by 3. Okay, this will be theta plus 2 theta by 3 is 5 theta by 3 plus 1.5 MP into 5 theta by 3, right? So this is our internal virtual work done equation, which is equals to external virtual work done. External virtual work done will be 5W into 0.5 W into 4 theta plus W into 5 theta plus 0.5 W into 3 into this theta. This is 3. So through trigonometric relation, this is 3 into 5 theta by 3. Okay, this is our external virtual work done. So if you solve this equation and calculate the value of W, we will be calculating the value W now. So this is 2 plus 2, this is 0.5 plus 1, again this is 0.5, this is 0.5, this is 2.5, this is 2.5. So this is 10.5 MP into theta. This is equals to, this is 7. This will cancel out. This is 5, 7, 7 and 8.5. This is 2.5. Okay, this is 2.7. This is 9.5 W into theta. So this will be equals to 9.5 W into theta. Theta will cancel out each other. So 10.5 divided by 9.5. So this value comes out to be, W comes out to be 1.105 MP. Okay. So when you are combining mechanism 1, mechanism 1, mechanism 2 and mechanism 3, the W value comes out to be 1.015 MP. Okay. So we have discussed all the combinations over here. Okay, I hope this problem is clear, will clear to you. Okay, and basically in this problem we learned different things. When we combine these three mechanisms, how you need to calculate the work done at the internal hinging. Basically, if this member is rotating, these two members are rotating in same direction, then you need to take the difference. Okay, you need to take the difference between the rotation. Okay, that was an important part over here. Okay, so guys, if you have any problem in this question, and if you want to discuss anything, you can write in the comment section. Okay guys, so thank you very much. Okay.